Hello everyone. Today I'm going to show you how we define a lane full of the bands that we want to try and compare to our database full of 1D gels and blots. So following on from my previous tutorial video of CLIQS 1D Pro where I showed you how to bring together all your different images of gels and blots to start forming your database, within the composite lane management section of CLIQS 1D Pro is where you define what you're going to search for within your database, what bands are you going to try and identify matches for within your database. Now, within CLIQS, you can do this two ways. You can have just a single lane, and you want to search for all of the bands that are in that lane within your entire database to see if there's any matches amongst your samples. But what you've also got the option to do is build a composite lane. Now, this is a synthetic lane, i.e., it didn't exist within your gel, but we can piece it together to make a synthetic version of it. So a synthetic lane or a composite lane is exactly that. It's made up of different lanes put together to form a synthetic lane that contains all of the bands that you would be searching your database for, even if in your original experiments they weren't all on the same lane. So that's a bit of a kind of complicated thing to get your head around, how you can search for things that weren't together in the first place, but I think it'll become more obvious when I show you how we build those. So one use case for this is if you had samples that were run on multiple gels and they were the same bands in each gel, but because they were done on different gels, they ran slightly differently and the bands were in slightly different places. Now, obviously, if you had bands in slightly different places on your standard lane, even if you searched your database for that standard lane, there would be some slight difference between which standard lane you use as to the matching profile that you get. So that's the benefit of creating a composite lane. So I will just show you what I mean by this. So I'll just create a new composite lane and I'll call this standards. Click OK, and you can see I've got it here saved in my database. So we will then, if you wanted to just compare one lane and find other matching lanes within your database, you would just add one lane to this composite lane, or you can build it up from many. So if you have a look in the center panel here, this is all of the lanes that were in all of the images that I've used to form my database. And it's got all of the names of them as they were decided in CLIQS. So that's brought forward into CLIQS 1D Pro as well. Now, I've not got very many images in my database. I've only got 2 images, as you saw in the previous tutorial. However, if I had hundreds of images, we've got the ability to search within our database to filter this down for you to easily find them if you want to make, your composite lanes and find your lanes for matching. And this works very much like a normal search bar. You have your gel name, and then you would, type in your criteria, click OK, date of experiment, any comments that are amended to your gel images or lane images. So again, that's comments that were either defined in the previous step in the lane fields or were defined in CLIQS. You can search for those. So if you were doing a particular drug treatment, for example, you would type the name of the drug in the comments box here that was matching when you did your analysis, and then hit query and it would filter down this list. So that's why we've got this section here for searching your larger database. So there's lots of tools built into 1D Pro that are very heavily focused on searching your database and making it very easy to find what you need to. So as I mentioned before, a synthetic lane or a composite lane is made up of sublanes that are merged together to create a master lane that is then compared to everything else in your database. So to add lanes, you just left click and drag them across here. And as you can see, I've got a lane 2 here, lane 3 there, lane 4 there, sorry, lane 6 there. And you can start to see that it starts building up this profile of your different lanes. Now, because we want to condense this down into one synthetic lane, the first thing we need to do is actually match these lanes to each other. So once you've got your sublanes in this section here, you're going to want to go ahead and click on Match Lanes. Now, the matching parameters, and this flows all the way through 1D Pro, define how rigorous the matching is. So the RF vector controls how close a match needs to be and how large these green lines are, how close the bands need to be to each other for it to be considered a match. So it's basically the tolerance of the matching algorithm. And the percentage of lanes band is in is that relates to how much of that band needs to be within the scope, within the kind of the standard error of this RF vector for it to be considered a match. So again, these two functions basically control how strict it is for matching or how loose it will be for matching. So and then this is another thing that carries on through all of 1D Pro as we go along. We've got these red spots above this value here is our RF value. And if we click on those, these red spots indicate potential matches. And as you click them, it allows you to visually see where the matches lie. And we'll do this further along when we come to the main matching section. But for this moment, we need to define our composite lane, our synthetic lane, we need to make these lanes into one. So we need to match them and then merge them. So I've just done the matching section there, and you can see this is the profile that it's given us when we consider all of our lanes put together. So if I click on make lane here, this is exactly what it's doing. It's condensing those three lanes into one lane basically, and then you'll see that this section here is populated. So our composite lane now, which is made up of standards, it's not really standards because I don't have standards in this experiment, but that's the kind of use case that you would use it for. This is what our composite lane is going to look like. So it's going to search for bands at these points along the RF line, and it will search for, and this is what the profile that it's trying to match is going to look like. So again, this is kind of a complex thing to get your head around, but for most people, they'll probably only be looking for one lane. They want to compare one lane to the rest of their database, or multiple lanes to the rest of their database, in which case they would just add one sublane to their composite lane. But if you had, for example, standards that you ran in every gel and you wanted to accommodate for any deviances between different gel runs in your standards before you compared your standard to the rest of your database, this is how you would do it. So this is what composite lane management is and means. So I'm gonna leave it off there, and then I'll create another video for the next step in the process, which is the define lanes and set management tool. Another thing to note here is when you do matching in the composite lane, and when you do matching in your database as a whole, there's algorithms that sit behind CLIQS 1D Pro that account for any deviation and any change in your gels between different runs. So that's what makes 1D Pro really powerful for comparing lanes across different runs, is that it can take into account changes in RF. Say if you've run one gel for longer than another and your bands are in different places, but they're the same band, we know they're the same molecular weight, the same protein, it will find those, it will accommodate for those. So even if there's some kind of operator difference or operator error between your gels, your runs, your blots, CLIQS 1D Pro is powerful enough to tease those out and treat everything as if it was all one large experiment run on a huge gel. So it allows your results to be comparable to each other, which is a really powerful feature built into 1D Pro versus trying to analyze lots of different individual gels and then make comments, observations, hypotheses on, say, 12 or 20 different analyses when the experiments were performed by different operators at different times using slightly different, molecular weight ladders or different conditions. So that's the real power of 1D Pro, and allows you to do these very long, kind of large longitudinal studies or QC studies where you're doing lots of runs over a long period of time, but you still want to be able to accurately and scientifically compare your results across those different runs. As ever, thanks for listening. If you'd like a free trial of CLIQS 1D Pro to explore its features and see how it could help you in your laboratory or work environment, please check out the links in the description below.